Hi, Prof. Rassi here again. This is the video you've been looking for, the last one in this series, and it's called the number E. And many of you right now are thinking, the number E? Isn't E a letter? And you're exactly right. E is a letter, but E is a letter that stands for a number. And this number was discovered by Leonhard Euler, and this number appears naturally in different situations and is called an irrational number. It's kind of like we could have the analogy to pi. Pi is a Greek letter that we use and you're comfortable using for 3.14159, so on. E is similar. Whenever you see the letter E from here on out in a math problem, you need to think 2.71828, so on. So first of all, let's find this button on your calculator. If you've got your graphing calculator, look around, look at the manual. If you have a TI, there's two places you can find it. One is second divide symbol. The second divide symbol, and then you can just hit enter and you can see that number. Often we're going to write e to a power, and so there's actually a shortcut for that as well. Second, and then the ln button, which is kind of by the 4, and that gives you e to a power, and you could type a number in 1, 2, 3, and that's actually the first thing we're going to do here. For number 11, we're going to graph e to the x. Now, if you think about this, remember E is just a number. This is really just 2.718, etc. to the x power. If you think about what you've learned so far about exponential graphs, and you think about it, you'll know, is this exponential growth or exponential decay? Hopefully you said growth, because that number 2.718 is bigger than 1. It is going to be an exponential growth. There's no transformation, so again, if we would make an XY table, I'm going to kind of shorten it up a little bit, 0, 1, and 2. Anything to the 0 power is, hopefully you said 1. 2.718 to the first power is just going to be 2.718, and to e to the second power is going to be about 7.4. And so that gives us a few points to graph. 1, 2.7, and 2, 7.4. Oops, not there. Yeah, that was right, 7.4. We know it's an exponential function, so it's got a horizontal asymptote here at y equals 0. And it looks something like that. I'm going to try that again. There, I like that better. All right, so what happens here? If we look at number 12, you notice it's very similar. How is it different? Hopefully you're noticing this negative symbol. And if you think back to transformations, when the negative is inside the function, here that negative's inside, it's going to reflect it. Where'd it go? It's going to reflect horizontally, so it's going to flip horizontally across the y-axis, which again makes sense. Remember negative exponents? It's going to put it in the denominator. So this is the same as 1 over e to the x. So it's going to be similar to this graph, but it's only going to flip across the y-axis. So we're still going to have a point here. That one's not going anywhere. Instead of being at 2.7 on this side, it's going to be at 2.7 over here. And instead of being 7.4 on the right, it'll be 7.4 on the left at negative 2. Again, the horizontal asymptote didn't change. That's still at y equals 0. but now we have an exponential decay instead of an exponential growth. Okay. And the last one, this one's a little bit of a trick here. You'll notice there's no x, it's just the function equals e. What that's saying is the function is equal to a number, which is 2.718, right? Yep, 2.718, so on. What does that look like? If you think about making an XY table here, you wouldn't need to. But no matter what I put in for x, my function's always going to be 2.718, 2.718, and so on. So I just end up with a horizontal line here at y equals e, 2.718. All right, in this last section, we're just practicing transformations again. You'll notice it says describe how each graph can be obtained from the graph of a basic exponential function. So we don't actually have to graph here. We've got a few things going on here. We got the negative sign, we got the 2.8, and the plus 6. So the parent function, or the original function, is e to the x. The negative here is going to reflect, it's on the outside, so it's going to reflect vertically across the x-axis. Do you remember what the 2.8 is going to do? 2.8, 2.8 is going to be a vertical stretch. And the plus 6, what's the plus 6 going to do? It's going to shift vertically up 6. All right. Let's look at the next one here. Again, this is another one. It might be easier to see if we rearrange things a bit. Put that exponential part in the front. We see we have 3 things going on again. So we've got the negative here and the 2. There's really 2 things there. And then the plus 1. So again, same parent function. Here the negative is going to cause a reflection. Since the negative's inside, it's going to reflect horizontally across the y-axis. The 2, it's also inside, so it's going to be a horizontal, and horizontal is always opposite of what you would expect. So instead of a horizontal stretch, it's a horizontal shrink. And the plus 1, a vertical shift up 1. And so really, don't be afraid of this e. It's similar to our other exponential functions. It's just using a number to take place of it's using a letter to take place of the number. And so anytime you see it, it's really just a exponential function acting like the other exponential functions we've seen. Thanks for watching, and let